All right, so this is for day 25 in section 1.3, the CEMC work for scalar equations. This is question number 3. So it says, write a set of possible parametric equations that describe each of the following lines. I'm going to go through A with you. The rest are the exact same. Answers may vary, so just because you don't get the exact same answer that I'm going to get doesn't mean that you're wrong. As long as you follow the same process that I'm going to describe right now, your answer should be right. So the first thing that I want to talk about, is when you think about a scalar equation, what you're really thinking about is something that looks like this. So ax plus by plus d equals 0. Now obviously, if we're adding a third dimension in here, there's going to be a plus cz, but for part A, we only have x and y, so we can just stop here. What we know is that AB is my normal. So this is a vector that is perpendicular to my direction vector. I also know that the x and the y, so this and this, those just represent a point on the line. Okay, so from this particular question, when I look at it, I know that I have my normal as 5, 1. My coefficient in front of the x is 5, and the coefficient in front of the y is 1. Now what this can help me find is my direction vector. So my direction vector could be multiple vectors. I just need to have a vector that is perpendicular to this normal, because remember, the normal is that vector that's perpendicular. So to do that, I need to think of some vector whose dot product with my normal, I'll just use xo and yo, that dot product needs to be 0. So I can come up with any vector whose dot product is equal to 0, and to do that I'm just going to choose one of an easy one. I'm going to switch the numbers, so instead of 5, 1, I'll have 1, 5, but then I'm going to have to make one of them negative. So let's just double check here. I would get, I'll just use a different color, 5 times negative 1, that's negative 5, plus 1 times 5. And that gives me the 0 that I want. So now I have a direction vector. So I'm halfway there. I need to now come up with a point that is on this line. Now again, there's a whole bunch of points on this line. I'm just going to circle that because it's important. So I need to come up with a point that satisfies this original equation. So 5x plus y plus 10 equals 0. I'm going to just choose an x of 0, because I can see right away that if I do that, if I do 5 times 0 plus something plus 10 equals 0, I can very obviously make this a negative 10. So if I use the point 0 for x, negative 10 for y, I know that that is on that line. Likewise, I'll just erase these. I could choose another point. I could choose negative 2 here and 0. 5 times negative 2 is negative 10, plus 0 is negative 10, plus 10 is 0. So another point that I choose could be negative 2, 0, okay? And again, there's hundreds of millions of them, so you don't have to worry about having the exact answer as me. So, final answer here. I know that my direction vector is negative 1, 5, or a direction vector is negative 1, 5. I know that a point on the line is 0, negative 10, so I can start writing this out. I have xy is equal to my point, so 0, negative 10, plus t times my direction vector, negative 1, 5. Now from here, I can start writing my parametric equations. So x is equal to 0 minus 1t, and then y is equal to negative 10 plus 5t. And I think that this is the exact one. Let me check. This is the one that I'm sure they did. Yes, this is the exact one that they did. Obviously, they just didn't write the 0, and that's totally fine.